our topic is the transition state versus intermediate. What is the difference between transition state and intermediate? There are two terms, and two terms are very different and very important. In assessment point of view, question may be asked about difference between transition state and intermediate. In any chemical reactions, if we discuss graphically, potential energy graph is drawn between potential energy and reaction coordinate, and reaction progress in this way, uh, like a wave like structure reaction progress in this way. So in this reactions progress just wave like. So as we know that in a wave, upper side is called maxima, and minimum side is lower side is called the minimum. So maxima point is with respect to, yeah, indicate and related to the transition state, and the minima and lower side is indicate and relate with the intermediate. So this is the uh, one difference between transition state and the intermediate. Graphically, this is the first point. Difference between transition state and intermediate is, in graphically, upper or maxima point is the transition state, and graphically lower or minima point are intermediate. And the second point of difference is that transition state is that state of reactions in chemical reactions. Transition state is the point uh, which is present in the reaction but cannot capture. Present in the reaction but cannot capture. So very shortly moment of a time is the transition state. Transition state cannot be captured. Cannot be captured, or we say that transition state is not isolated. Transition state cannot be isolated practically in reactions. So if we cannot isolate that particular point, or we cannot capture that particular point in a reactions, in any reaction which are uh, going on. So when reactions is progressed, so we cannot isolate or capture that point. That point is present but cannot capture and isolated. We say that that particular point is called transition state. It is just like I give an example, an analogy here. If someone jump, so when someone is jump from the ground state to uh, upper point or higher point, so that point is very short. When a person jump upward and comes down, uh, very few second, and a few second a person remain in the air. So a person remain in the air in a very few second of a time. So we cannot stop a person in the air. If any person jumps in air, we cannot stop, isolate that point. A person is jumping in the air, this is a point we cannot isolate. So that point is called the transition state. In intermediate, somehow we can isolate that point, that is called intermediate. Yes, if any person is jumping and we want to capture that point in a very in specifically, if we take a photograph, then that transition state can be indicated and represented in photograph when a person having very short period of in a second 1 second. So that 1 second point is can be represented in a photograph. If we take a photograph, a person is jumping in the air, although practically that point is cannot be isolated. So that point is transition state. That point is transition state. In the second graph here, a compound is given CH3Br alkyl bromide, and reacted with the Cl negative and converted into CH3Cl and Br. Uh, this compound, this reaction is called the, in fact, a nucleophilic substitution reaction. It is example of nucleophilic substitution reactions. What happened? First point of attack. First of all, here we discuss point of attack. Attacking species is attacking species is Cl negative. Attacking species is the Cl negative. Cl negative. Cl negative attacking the uh, CH3. CH3. This is a CH3. CH3 attacking species attack the CH3, and Br, which is also present with the CH3, that CH3 Br is leaving. That leaving. So here one bond is making and second bond is breaking. So two type of bond is here shown with the dotted line. Shown with the dotted line. Suppose I draw here the diagram. Compound, organic compound. This is organic compound having CH3. So attacking species, suppose we have attacking species Cl negative. Cl negative here attack with carbon. Cl negative attack with carbon. And Br is also present, but that bond is Cl negative is attaching with carbon. Br also present with carbon, and that bond is now breakdown. Start breakdown. So one bond is forming, this bond is new bond is forming, and old bond is going to break down. So these two processes occurring simultaneously. These two processes occurring simultaneously, and at that point of reactions, this stage is called transition state. New bond formation and old bond breakdown occurring very rapidly. We cannot isolate that point. Theoretically, we are drawing in the paper and representing how bond is making and how bond is forming. But in practically in actual practice, we cannot see these two processes occurring because both processes are very rapid and occurring simultaneously. We cannot isolate. So such type of reaction, we can say that at the particular point, this particular point, uh, we say that in a reactions of that point is called the transition state that cannot be isolated. That cannot be isolated because both are forming and making and very rapid point here. And what's about intermediate? Intermediate step, intermediate step in a reaction is that point which can be isolated, which can be isolated. We say that this is intermediate, and transition state cannot be isolated. How intermediate is explained with respect to chemical reactions, as we explained transition state with examples. If we have organic compound, there are three alkyl group attached with carbon and one side bromine is present. And if somehow reactions is carried out with a polar solvent, or we say that ionic solvent, polar or ionic solvent. Polar condition are those conditions, ionic condition are those conditions when molecule is ionized. It means molecule or compound will be ionized. When molecule is ionized, Br will be isolated and that portion is also isolated. Here focus, I am drawing the ion. Focus at that point. Now bromine is not a part of this carbon. That means carbon is plus and bromine have now left the carbon, so bromine will be negative, Br negative. So two ion, cation and anion is formed, plus and negative. These cation and anion can be detected and isolated in reactions. Cation and anion can be detected and isolated in a reaction. So that point is that particular point in a chemical reaction having the uh, lifespan. Lifespan means they are present in reaction quite particular reactions, a particular time. At particular time of interval, these ions are present. So these ions can be isolated and preserved. So we say that this is an intermediate state. Although these ions react with each other or opposite ion and forming a new product, but these ions are at intermediate state can be isolated. So when these ions are isolated at intermediate state, we say that this is how somewhat stable state. Stable. Transition state was not stable. Convert immediately into product. Intermediate state somehow is stable state. Although intermediate also changing into product, but it is an intermediate state, it is stable state, can be isolated and preserved. The Hammond postulate. Next is, what is the Hammond postulate? Hammond postulate mean CH3Br react with Cl negative. So what happened when this reaction is carry on a progress? So energy term of, in term of energy and graphically, two graphs are representing here exothermic and endothermic reaction. So in generalized structure, endothermic and exothermic reactions are present. So such type of the postulate is called the Hammond postulate. Hammond postulate means uh, two type of reactions as here indicated in the first graph. 2 points are indicated here in a green box. Both these two green boxes are very close to each other with respect to energy. So with respect to energy terms, these 2 points are very closer to each other. So we cannot say, looks like similar point. 2 points are looks like very similar. Structurally and energy point of view, they are just very similar. So this is called the Hammond postulate. Hammond postulate. So structurally here are represented, and energy in point of energy here two graphs are represented. See here, reactant and transition state. Reactants and transition state are very closer with respect to energy. Reactant and transition state are very closer with respect to energy. Here product and transition state are very closer to with respect to energy. So with respect to energy, transition state and product are closer, reactant and transition state are very closer. So in energy point of view, when 2 points are very closer, we say that this is a Hammond postulate. Or structurally, if they are the similar, we say that this is a Hammond postulate. So I think this is sufficient for today. Next 6.7 is a different topic, nucleophile, electrophile. We will continue in the tomorrow's session, the next session. Any
Okay.
question?
Okay. No, I get.
Okay, thank you.